Okay, this one comes from an old high school friend of mine, and she was asking about interval notation and graphing when we're dealing with inequalities. Now, to cover what inequalities are, let's talk about equalities for just a second. Take a little time out from the problem. You're used to seeing something like x equals 2. Well, this is an equality. It's got an equal sign in the middle telling us these two sides are actually the same. X is equal to 2. But we don't always have this. All nice, pretty wrapped up package. Sometimes we get something like this, where x is less than 2. So these two are not the same. They are not equal. They are unequal, making this an inequality, because x is not the same as 2, because x is less than 2. So when we start to get into inequalities like that, let's have a look at them. Where we have something like x is less than 1, or x is less than or equal to -5, which means that it could be equal to -5, but it's not necessarily equal to -5. And we're going to graph these out in a second to find our solution interval and show the interval notation for it. Now, in the old days when I was in high school, what I learned was an open dot and a closed dot. And what the open dot meant was that the number that you're graphing from is not included in your solution set. And by the way, the solution set is just basically the numbers that would make this inequality true, are a number that you can plug into that could possibly make it actually into an inequality. Like here, x is less than x is less than 1. If x is less than 1, we know x is not equal to 1, so you'd be using the open dot. But here, x is less than or equal to -5. So again, it could be equal to -5, so you'd use your closed dot. Well, in the new textbooks, they decided that was just way too clear, I guess. So they've switched to parentheses and brackets. Parentheses representing your open dot and brackets representing the closed dot. So let's graph these out and see if we can come up with an interval that works for our problem. Now it's going to be in no way to scale and probably pretty messy because I'm drawing it by hand. So here is our number line. And I'm just going to randomly throw a 0 in right there. That's about the middle. At least from where I'm standing off a little bit to the side of the board. So let's start out graphing our top one here. X is less than or equal to -5. So again, not to scale. Just going to throw -5 in right there. Now, we got to come here to our graphing notation, and we notice that since this is equal to me, it could possibly be -5. We got to use our bracket. So we give it a bracket. Now we go to the next thing. It says less than -5. So everything this way on down to infinity, could be a solution. But we also have to meet this other criteria because we have this and between our two inequalities. So we also know x is less than 1. So we're going to throw in, sorry, that's not negative. I know it's on the right side of the 0. I can hear y'all screaming. We're going to randomly throw 1 in right here. So we look back to our notation. We know that x is less than 1. We know x is not equal to 1. So we're going to go with our parentheses right here because 1 is not included. We know it cannot be equal to 1. So we do know the next part, less than. So no, we all go this way down our line all the way to -infinity because our inequality didn't give us any cutoffs. -infinity down this way. I promise this infinity probably doesn't really look like it. Okay, now our next question, we're looking for possible solutions, is where do these two lines cross? Because that's the only place we can have a solution because that's the only places that meet both of these inequalities. And if we look right here at -5, and remember -5 is included in our set because x could be equal to -5. We know we've got that right there all the way down. These lines cross all the way to -infinity. So we're going to set up our interval notation, and we're going to use these, and that's probably why they switched to them, so they could use them in both graphing and interval notation. I still like the dots, but my opinion doesn't get to count anymore. Something a little weird is going to happen here. Just remember, when you're using infinity, it's not really so much a number as it is a concept, so it's not actually included. If I could draw an infinity symbol, it's not actually included in your solution set, so it gets a parentheses. Now, the other end of our solution set is going to be here at -5, because we know everything over here is where the lines don't cross all the way positive infinity. We know the lines don't cross any farther past that, but we know they could cross at -5. So -5 gets a bracket. This is your interval notation, and here is your graph. Any questions? You can just throw them on down there in the comments.